we would like to sketch an approximate solution of this initial value problem in a qualitative manner, okay, as our particular section is about. All right. So first thing we would like to note is that what are the equilibrium points, that is, for which values we have no change occurring in y. So you can see y sine y is 0 for y equals n pi, because if you take n equals 0, y is 0, so this value is 0. Or for n pi, sine of y will always be 0, so this is 0. Okay. Now let's pay attention to this initial condition, that is y at 0 equals 1. So if we look at that, then you can see that y equals 1 is enclosed between what? The equilibrium solutions 0 and pi being approximately 3.14. Okay, so we shall go with this and try to sketch a solution. Now to draw a vertical line, choose this line tool, okay, and just click the left side of the mouse. If you are using a computer that I am, press the shift key and go vertically. All right, and similarly, now we draw the solution y equals 0. You can see we have created the axes and made the tick marks. So here I am just keeping the shift tab pressed to make this horizontal line y equals 0. Now our initial condition is that at t equals 0, y equals 1. So let's make a dot here. All right, so we will go ahead and mark that point on the axis. Okay, so here we go. So we need, or we want to sketch a solution that passes through this point 0, 1. Now we are going to recall our equation to understand the nature again. So here is our original equation, and notice this, that if we take the values of y between 0 and pi, and 0 and pi excluded, then this product will be what? Product of two positive quantities will be a positive quantity, which means what? Which means that our solution will be, or the graph of our solution will be an increasing solution, and the graph cannot intersect y equals 0 or y equals pi because of the uniqueness condition, because the uniqueness condition is satisfied here. Okay, so we can go ahead and try sketching that. I'm not very good with this. So since I was not very good with the pencil, I will try to use a different tool, that is this wiggly one. What it does is, say you sketched it, you can, oops, sorry about that. What did I do here? Okay, so yes, you sketched it, and then you can turn it around and everything. So before we do that, let's notice some more things, even though we are not required to. So you can see we have an autonomous equation, okay, and we know that the solution has to pass through this, and the graph is going to be an increasing graph, okay, but of course it'll have to turn somewhere here. So let's see, how do we determine at least approximately where it's going to turn. So you can use your calculator, or you can use a spreadsheet to determine that point. So we are going for y between 0 and pi, and 0 and pi excluded. So let's go in the increments of 0.1, okay, and let's go up to here, a little below pi, okay. And what this will be, the dy dt will be the first cell times and sine of the second cell, as I did, and then once you see this plus sign, double click on this, and you got all the values. So you can see all the way up to like about 2, the dy dt is increasing, so the function will be concave up, and here after that it goes on decreasing, so on that part it will be concave down. So what we can do is that, well, we have that chosen, and then here at 1, I mean, you just try to be as careful as you can to see that the slope is like 1 times sine 1, which will be like about 0.8, little less than 1, and we will slowly try to complete it by using that tool if we are just doing it approximately. So here is a completion with a lot of struggle on my part. All right, and you can see we have a point of inflection here, even though you are not required to show this for these particular exercises. Okay,